Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about one of the most difficult concepts in calculus. It is logarithmic differentiation. This is going to be much harder than just derivatives of logs, which I talked about in my last video, which you can check out in the description. But these are going to be problems like this. There's two families of functions where we want to use logarithmic differentiation. The first family is when we have a product rule and a quotient rule in the same problem, especially when we have a lot of things raised to some exponent like this. This is the first time we use it. The second time we use it is when we have x in both the base and the exponent. So these are the two kinds of functions we're going to be looking at today. Luckily, you solve them both in the exact same way. And so let me show you how we solve both of these problems, starting with the left one. So the first thing I do is I take the natural log of both sides. As the name implies, this is called logarithmic differentiation. So the first thing we do is we take the natural log of both sides. Now you may be thinking, why on earth did we do this? This just made the problem harder, not easier. Well, the truth is, it did make the problem harder, but that's because it's about to become a whole lot easier, and that's because we have our properties of logarithms. So let me show you. Keep the left side the same, don't touch it, leave it as natural log of y. On the right side, look what I do. I have multiplication in the numerator, and the division bar means division, obviously. So I've got division in the denominator. So in other words, what I'm saying is I can split this up into three logs. The first one is natural log of x plus 2, and then since the 2x squared plus 1 is in the numerator, it would be plus natural log of 2x squared plus 1, and then last in the denominator, because it's division and it's in the denominator, it's going to be minus natural log of 6x plus 9 cubed. Now in case you're wondering, how on earth did I do this? This is a pre-calc concept. This is not even the calculus part yet. So if you're having trouble with that, I cover this in a different video. You can check that out. But assuming this all makes sense, then I'm going to keep moving on. Again, before I'm taking this derivative, I want to rewrite the last term, because if I have anything raised to a power, not the 2x squared plus 1, because only the x is squared, I'm saying when everything is raised to a power, like 6x plus 9 cubed, I can pull the exponent out in front, so that 3 goes out in front, leaving me with just natural log of 6x plus 9 to no power, no exponent now. And on the left, I still have the natural log of y. Okay, now the next step. This is the fun part. I need to take the derivative of everything. That means the left half and the right half. So I could give you a very formal answer of how to find the derivative of the left side using logarithmic differentiation, but I am not going to do that. I'm just going to tell you the shortcut, because the derivative of the natural log of y is the exact same thing every single time, so you can just memorize this solution and you'll be fine. The natural log of y, there's two ways you can write this derivative. I don't care which one you do. You can either write y prime divided by y, or you can write 1 over y times dy dx like this. Now a lot of my students like the first way, but since I was taught the second way in high school, that's the way I feel more comfortable, so that's the way I'm going to do it. But we'll get the same answer either way. So that's it for the left side. Now for the right side, we're just taking the derivatives one at a time. So first for natural log of x plus 2, that's just going to be 1 over x plus 2. If you don't know how to do that, then you probably shouldn't be watching this video. You should be watching another video explaining the basics of derivatives of natural log, which conveniently enough I have done for you. You can find that in the description. And then for the derivative of natural log of 2x squared plus 1, that's going to be 4x over 2x squared plus 1. And then lastly, the 3 is a coefficient. It just goes out in front. Times 6 divided by 6x plus 9. And now I'm going to try and simplify the right side. So for instance, when I look at this, the first term cannot be simplified. The second term also cannot be simplified. No, the 2 does not cancel, nor does an x cancel, because the plus 1 kind of ruins that for us. But in the last term, a 3 can cancel, because this 3 can cancel out with that 6, leaving you with the 2, and the plus 9 becomes 3. and that 6 in the numerator just stays the same. So in other words, we get 6 divided by 2x plus 3, and that's the right side. Notice I'm not circling this as the answer because the left side is still 1 over y times dy dx. So what I would say from here, there's only one thing left to do. This is always the last step in a logarithmic differentiation problem, and that is you need to multiply both sides by y. Let me show you what that looks like when you do it right. So first, for the left side, the y is going to cancel with the 1 over y, just leaving you with dy dx. And on the right side, I just put the whole thing in parentheses, like this, and then just put a times y at the end. Now technically, we're not done here, because y did not show up in the original problem. So how I remedy that is I just have to replace y with the original problem. So first, let me write out everything else again. And now I just replace y with the original problem, which was quantity x plus 2 times quantity 2x squared plus 1, and then in the denominator 6x plus 9 to the third power. And there we go. There's our nice, easy final answer. As you can tell, this is one of the most grisly types of problems in all of calculus. This answer makes me want to throw up. But regardless, this is correct. And I suppose there's a couple correct answers depending on how you simplify this. But this is how I did it. And I would probably say it's the best way to do it. So that's it for this one. Now just one more I want to show you. This is the second family that requires logarithmic differentiation. And that's when you have x in the base and the exponent, like this problem. So the good news is, again, the first step is the same. If you forget what that was, it was taking the natural log of both sides, like this. And again, before we take the derivative, the reason why you're doing this, why you're taking the natural log of both sides, is because we can use properties of logarithms to simplify this for us. Do you know what the simplification is? That's right, boys and girls. You want to pull this x plus 1 out in front using the exponent property. So we got quantity x plus 1 times the natural log of x. If you want to put parentheses around this, you can. Honestly, it doesn't matter. You definitely need parentheses around the x plus 1 though, because it is a quantity. And then on the left, don't change it yet. It's still the natural log of y. Now the next step is taking the derivative. If you want to try and take this derivative on your own, go ahead, you can pause the video. However, I feel like a lot of you are not going to know what to do, and that's because you just missed the product rule, because you've been missing the product rule all semester, and I don't know what to tell you at this point. But anyways, here's the solution. As we said earlier, the left side is always the same, 1 over y times dy dx, or if you prefer, you can write y prime over y, that's fine too. For the right side, we do have a product rule. That means f times g prime plus g times f prime. In other words, let me just write it out for us. F of x is x plus 1. G of x is natural log of x. F prime of x is just going to be 1. And g prime of x is going to be 1 over x. And that's because hopefully we know the derivative of natural log of x by now. So anyways, plugging in the formula, it is going to be f times g prime plus g times f prime. And so if I rewrite this and simplify it a little bit, on the left I'll get 1 over y dy dx, and on the right, numerator is x plus 1, denominator is just x, and then plus natural log of x, because anything times 1 doesn't change it. And then of course the last step is to multiply both sides by y, and I'm also going to put this bit in parentheses because that's good notation, and then times y, like that. Or you can just go ahead and write what y stood for, which was x to the power of x plus 1. And there we go. That's going to be our final answer for this one. If you do have any questions about this, please let me know in the comments. That's all the problems I want to look at today. Thank you all for watching, and I'll see you in the next video. Take care, and bye-bye.